Hi, and welcome to my video. Today I am going to give a general overview of operating systems, and more specifically the most popular three operating systems, which are macOS, Linux, and Windows. But before I get started with this video, I want to note on one thing. Operating systems are extremely complex, and they require understanding many different computer science topics that you will learn through 100, 200, and even 300 level classes. So this video should not be seen as a complete overview of operating systems, as there are entire classes taught on operating systems, but this should be seen as a high-level general overview of operating systems. So before we talk about the specifics of what makes each of these three operating systems unique, let us first understand what an operating system is. Before an operating system is applied to a computing system, all we have is a box of bits and gates that cannot do anything. It is just useless hardware. So what the operating system is going to do is it is going to add a layer of software between the hardware and the user so that whenever the user writes a program, it is able to be run on the hardware. The operating system is going to act as the middle layer between the hardware and the applications or the user. So in other words, the operating system is going to enable the user to be able to use the CPU, the memory, the input devices, and the output devices. And although all operating systems are very unique in and of themselves, every operating system must have some common features. The first of which is input and output management. The operating system is going to manage whenever input comes in or whenever output needs to go out. So for instance, if someone hits a key on the keyboard, or if someone's talking into the microphone, or if something comes from secondary memory that needs to go in RAM, or if something needs to go from RAM to the CPU, those inputs are going to be written somewhere, and that writing would be the job of the operating system. Outputs, on the other hand, you may need to show something on the screen. You may need to print something. You may need to write something to memory. Well, that is also going to be the job of the operating system. The operating system is also going to manage the processes running on the CPU. It is going to choose what programs get to run when multiple programs want to run. It is going to tell when programs need to stop running so another program can start running. It is going to assign cores to programs. It is going to manage all the processes that are running. It's also going to manage memory. Programs need memory. Programs need data. Data needs to go in memory. The operating system is going to control that. Whenever a program needs memory, it's going to allocate that memory for the program. Whenever a program says, hey, I no longer need this memory, it's going to get rid of that memory for the program or from the program and free it up for another program to be able to use. Because if one program is done using some memory, it should not hold that memory because another program may need to use that memory. The operating system is also going to structure all the files and folders, also known as directories, that are contained on your system. And we will talk more about that structuring in a later video. There's also going to be drivers that the operating system is going to need to take care of. And that basically is if you have to install something like a graphics card, a sound card, any extra piece to your computer that's not of the basic few pieces that are needed to be a computer, well, you're going to need some piece of software to tell your computing system what that new piece of hardware does, and well, that's what drivers are. Drivers simply tell a computing system how to work with a new piece of hardware that has been introduced to the system. There's also interrupts. Interrupts are pretty advanced for this class, so simply if there's a critical event that the system needs, an interrupt is going to be taken over by the operating system, or the operating system is going to handle that. It's going to stop everything that it's doing for that critical event. until that critical event has been resolved. We also have networking that the operating system will be in charge of, and that is talking between computers. We're not going to get too into detail with these last few because they are extremely complex topics that have their whole classes on them. And then also security is protecting the computer from malice, protecting it from attackers. That is also the job of the operating system. So as we can see, there are many things that the operating system is in charge of. It is responsible for managing all of the devices from the von Neumann architecture. It is in charge of managing the files and folders. It's in charge of making sure new hardware is able to run. It's in charge of making sure that anytime a critical event is happening in the computer, that critical event is being attended to. And it's also going to make sure your computer can talk to other computers, and that when it's doing that securely. So the operating system is a very important piece of software running in the background of every single computer. Now, let's talk about the three major operating systems on the market today. The first operating system I want to talk about is macOS. macOS is an operating system that is developed, maintained, and marketed by Apple Inc. macOS itself first came out in the early 2000s, but it actually dates back all the way to 1989. In 1989, an OS was released called Next Step from the corporation called Next, which was founded by Steve Jobs after he was fired from being the CEO of Apple. Next was a company that was a direct competitor with Apple, and after many years of feuding with Apple, Apple decided they had lost the war and decided to rehire Steve Jobs as the CEO, purchasing Next in the process, which eventually turned into Mac OS X, then OS X, and now simply Mac OS. Mac OS is based on the Unix kernel. Kernel is just another word for operating system. And this means that it is a multi-user and multitasking OS that has been designed based on the Unix philosophy. And we can summarize this Unix philosophy as 4 bullet points. 1, programs should do one thing and do it well. 2, programs and data are stored in a unified file system, and that unified file system is in a tree-like structure. 3, the output of one program can be piped to be the input of another program. And 4, systems should contain a shell scripting language and a command language to allow for complex workflows using the previous philosophies. Being based on the Unix kernel, it should be noted that Unix is actually a company which was originally developed by Bell Labs in 1969. Thus, to actually be a Unix-based operating system, as macOS is, Mac OS must follow a strict set of specifications set out by Unix. And on this bullet point 4 here, it should be noted that every Mac and, any Unix type operating system is going to have a program called Terminal, which will allow you to access the operating system and the file system through a command line rather than through the user interface that everyone is normally used to, such as your desktop. But we will talk more about this in a different video. And one last thing to note on Mac OS and Unix is that the directories and files, the file system in it is shaped in a tree-like structure, which looks just like this, but I will go over that more in another video. The next operating system I want to talk about, family of operating systems, is Linux. And this is Linux's logo, and this is Tux right here, the mascot of Linux. So if you ever see this penguin in computing, they're really talking about Linux. You'll see it a lot if you are a CS major. So we say Linux is a family of open source Unix-like operating systems. It is a family because it is not just one operating system. There are many, many, many different operating systems that are Linux operating systems. And 3 of the most popular, just to name a few, are going to be Debian, Fedora, and Ubuntu. Linux is a Unix-like operating system, well, because it does not follow official Unix specifications as macOS did, but the Linux kernel is basically the Unix kernel, so they are very similar, and that is why we call it a Unix-like operating system. So it is very similar to macOS, but it is a completely open source family of operating systems, meaning each operating system that is a Linux operating system, all of the code for it is available online to be further modified, or you can actually help fix bugs in the code through the open source initiative. And as with macOS, all Linux distributions come with the terminal, which is going to allow you to, well, use the operating system and the file system without having to use the user interface that everyone is used to. And last, but certainly not least, we have Windows. Windows is the operating system that has been developed, maintained, and marketed by Microsoft. It is the operating system that comes on any non-Apple computer that is purchased from a normal computer store. The Windows operating system is closed sourced and proprietary, meaning it is solely controlled by Microsoft. The code to it is not available online, and it can only be accessed by Microsoft employees and by people who pay for a license to this shared source initiative, which is just a thing owned by Microsoft. So unless you work for them or if you pay them a ton of money, you aren't seeing the source code for Windows in its entirety. You can view little bits and pieces of it at a time, but you cannot view the whole source code at once, as you would be able to do with something like Linux or some components of Mac OS. One major difference, though, between Unix operating systems and Windows is the way the file system is structured. So when there is multiple drives in a Windows system, each drive is going to be treated as a separate drive. And you can just think of those as separate cabinets in a filing cabinet. And each cabinet is going to have some folders in it or directories, and those directories can have more directories in them or other folders in them, or it could have files in them. This is very different from how Unix or Unix-like operating systems structure files and directories, because if you remember, they do them using a tree-like structure. So that is a huge difference between Unix and Windows systems. And there are many more differences between Windows and Unix systems, and I could turn this into a multiple hour-long video talking about the differences, but that would be beside the point I'm trying to get across in this video. So that is all that I have for you for this video. Thank you so much for watching, and I will see you in the next video.